this part here that's allowing that slippage to take place. It's also what provides the auto steering function, and that's a function that I've decided I can't live with. So I need to take the wheels off, get the axle out, and then see what I can do with that part. Let's go into some of the details here. So we'll just look at, the left plate and the right set of plates. Driving plates are pretty much identical. So to show you this one. So the driven plate you can recognize by the fact that it's got these extensions. I'm going to call everything teeth. So it has these extension teeth. It fits into this unit here. It engages with these teeth. It has a little bit of room to move around because there's some gaps in here. That's actually critical in how it operates as an auto steer mechanism. These two plates actually, they do come apart. I'm going to keep them together, but you can take my word for it. These plates can easily be separated. There's just grease in there now, and that, just that suction is holding them together. The back plate doesn't have these extensions. So by virtue of the fact that the front plate has these extensions and engages on the inner part of the main gear, and the outside of the main gear is, takes power from the motor through, a couple of gears and a chain. So this plate here is, with the extensions, is the driver or driven plate. The plate on the back is splined to the axle, and it does not have the extensions, so it's a slave plate. It gets its power from the driven plate. So obviously if you separate these two, this will no longer have power. This plate is driven by this plate is driven by the main gear. If you separate these two, the slave plate freewheels. Okay, so what determines, when they're held together and when they freewheel? So that's actually a function of the fact that the axles are coming in and the case is assembled. The maximum amount of play actually is where these teeth that are facing the inside of the plate stay together. It has a flat surface on top of it, and so does this. So when these are aligned, one on top of the other, there is no free play. And both left and right axles, slave plates are engaged to the respective driven plates. So what happens is when you apply some torque through the handlebars, to the wheels, it actually forces these flat surfaces out of alignment. And when that happens, it releases, you can see that there's nothing holding this plate back anymore. So this plate can now release from the slave plate, which will then disengage the axle. Once one of these plates is disengaged, the other one cannot disengage, because what's going to happen is the flat plane here will contact this surface, right? So in other words, only one axle can disengage at a time. Both of these driven plates are still being driven by this gear. So these two plates are still turning. And what will then happen is as they turn, these raised ridges, the flat spot on the raised ridges, will become realigned at some point. And this spring, by the way, is in between, forcing these outwards. And if there's no pressure, both these plates will then re-engage. And you've now got both wheels turning until, the torsional force is applied again, and then they separate until they find a new equilibrium. So, and that can, depending on where the torsion is applied on the left side or the right side, determines which plates separate, and then they get realigned and re-engage. So it's the ability of these plates to separate which causes the auto steer function. And auto steer is merely disengaging and re-engaging different axles based on torsional force, which are delivered from the handlebars through to the wheels. and then, across the axles and into this unit. So this spring then is providing some tension, which pushes the drive plate against the slave plate, but it's a weak spring, so it's easily overcome by the torsional force. You can shim instead of the spring, put a shim in. And what the shim would then do is it would provide actually, obviously, a non-springy separation of these plates. It would prevent them from separating. And if they can't separate, they can't disengage. They don't disengage, the wheels are always turning. So that would be essentially auto steer delete. Okay, so what shim material and how thick or what's the distance? So I took a rough measurement. I measured, from the channel, which the spring goes into, to this flat surface, and you can see a little thing there. And then obviously you double it because the shim has to go from this channel to this channel on the alternate driven plates. And it comes out to, somewhere between 12 and 14 millimeters. So I did a couple of models here. This is a 12 millimeter model shim made out of cardboard. Made it at 12 millimeters. Tried putting the plates together. Okay. And what I found is that at 12 millimeters, you can see that these raised teeth here on the front surfaces of the two driven plates, they overlap one another. So when they're turning and hit each other, they're being raised up. What that means is that there's a little bit of slack in there. And if that slack is too great, then the plates could separate, disengaging the clutch. So that shim is too small. So next I tried a 14 millimeter shim, cardboarded again. Okay, so 14 millimeters. And with 14 millimeters, you can see that these teeth are separated. What that means is that they are being held apart. They will keep the axle engaged. However, there's like a whole millimeter there of space, so I don't know if it's going to fit comfortably in the housing, or if the axle shaft has to, they have to meet together in the center and compress this washer. So and that's a little bit too high, 14. So I tried 12, I tried 14. There's, the only hole measurement in the center is 13. So I went directly to creating a shim out of 13. Now, just so happened I had an ABS 1.25" union. The inside diameter of the union is the same as the outside diameter of the pipe because it's a union. So I happen to have one sitting around. I tried it, and it just happens to be perfect diameter, perfect circumference to fit in the channel comfortably. Okay, is it okay to use ABS plastic? So when both these plates are locked together, what happens is they're being turned at the same time. So there shouldn't be any frictional force as long as this has enough strength to keep these plates pushed back, and the torsional force is not that great. So if that happens, then these two are locked together and they turn together, and this should turn with them, meaning that it shouldn't get hot. It shouldn't melt. 13 millimeter shim. And there we go. So now there is still a little bit of a gap, but it's better that the teeth be just a hair apart than they be too close together, because I don't want, as much as possible, I don't want any possibility of these driven and slave plates to separate. So, have I got it close enough? I don't know. When I go to assemble it, I guess I'll find out. Anyway, so reassembly is next. Put it back together, throw it back in the machine, and see if I've successfully deleted auto steer from this unit and I have 2 driven axles. That's the goal. I'll let you know. Alright, so here we go. Got the auto turn mechanism reinstalled in the shaft. And just need to button this up, give her a test, see how it goes. So the auto turn mechanism is reinstalled on the axle shaft in my snowblower. I did a quick test, and it does exactly what I wanted it to do, which is it basically locks up the auto turn differential and permanently keeps both wheels, both axles engaged. Going to be somewhat challenging to turn it. When you have to, in order to turn it, you have to skid the wheels around. So I'm not sure that this would be a good solution for the bigger, heavier Ariens models. I'm looking forward to using it this year where, it goes in the direction that I pointed it. Thanks for watching.